Hello everybody, we are here with another visual pattern challenge. Our visual pattern this time is these patterns of flying smiley faces in a V formation. So here's step one, a small V, here's step two, a bigger V, step three, a much bigger V. And your challenge is to figure out how many of these smiley faces will be in step number 4 of this pattern. And at a much higher level of difficulty, how many in step 43? And can you write an equation that you could use to predict the number of smiley faces in any step at all? If you'd like to accept that challenge, pause the video, give it a shot. All right. Well, I think this pattern is going to be fairly straightforward because it looks to me like we're just building off each arm of the V a little bit every turn. And let's see by how much. So here's step one. And we had 2 here and 2 here. So it looks like we're adding 2 to each side. Do we do that in the second one? So in the third one, here's the pattern from step 2. Yeah, we've added 2 more here and 2 more here. So it looks like we're adding 4 smiley faces every turn, every step. So if I wanted to predict the number in step 4, I would just add 2 more smiley faces on either side. And there we'd have it. Let's count these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I think that's 15 for step 4. Let's put that down here. We'll check that in a minute. Now, to get step 43, I think I want to write an equation first. It'll make it much easier. And to get that equation, I want to analyze the numbers. So let's do that. I'm going to put the step and the faces over here. So in step 1, we have 3 faces. In step 2, we have 4 more, so that's 7 faces. In step 3, we have 4 more, so it's 11 faces. And in step 4, we're predicting the 15 faces. And then we look at the differences. So between steps, so 7 minus 3 is 4, 11 minus 7 is 4, 15 minus 11 is 4. And this should make sense, right? We're adding 4 faces every step, so the difference between steps should be 4. The reason we take the differences is because if you find that it's a constant, it doesn't change, the difference stays the same every step, then you know it's a linear pattern. And we can use the equation of a line, y equals mx plus b, to model that pattern. And the m is going to be this change from step to step. So we'll rewrite this as y equals 4 times x, and x is the step number. And then this plus b, or maybe minus something, is a number we use to adjust it so that it works with step 1, and then we'll make it work with step 1, and then we'll test it with a couple of the other steps to double check. So if I used just this part of the equation, y equals 4 times x, I'd put in 1 for step 1 of the step number. 4 times 1 is 4. I'd get 4, but I only have 3. So I've got 1 too many from this equation. So I have to adjust that by subtracting 1. And that means we can put a minus 1 here on our equation. That's the b part. B was a negative 1. So our equation is y equals 4x minus 1. Let's test that, make sure we're on the right track with step number 2. So y equals 4 times step 2 minus 1. 4 times 2 is 8, minus 1 is 7. Yeah, there are 7 smiley faces there. Try it with step 3, y equals 4 times 3, step 3 minus 1, that's 12 minus 1 equals 11. Yep, that's how many there. And let's test with our prediction here in step 4. So y equals 4 times step 4 minus 1. 4 times 4 is 16, minus 1 is 15, and that's exactly what we predicted. So all this seems to check out. We can be confident that our equation is y equals 4x minus 1. And we can use that to calculate the number in step 43. So y equals 4 times step 43 minus 1. So 4 times 43, well, let's see, 4 times 40 is 160, 4 times 3 is 12, so that's 172 minus 1, that's 171 smiley faces in step 43. Well, how did that go for you? Did you get 15? Did you get 171? Let me know. Thanks, everybody.